So previously I made a technical review of the Eric Weinstein geometric unity paper, and it was very long. So now I decided to just give a brief summary of problems without much details, just for those who don't want to watch the whole video. So again, we need to start with his construction. So the idea is that we are considering the bundle of all metrics on our four-dimensional space X, and we start with the observation that the connection on this bundle naturally leads to metric on it. It is a fact reiterated here by Timothy Nanji and Theo Polly. So yeah, this part is more or less clear, and that's what Eric said in his Oxford lecture, but in his draft he writes something else, which is a bit more unclear. He called the Zora construction, where he chooses the metric on X, builds Levi-Civita connection out of it on X, and then somehow builds a metric out of this Levi-Civita connection on Y. In these notations on U, which then leads to connection on Y. And this is a bit unclear, and it's not really well explained here. My guess that he basically is thinking about this connection as a covariant derivative, and then he tried to take covariant derivatives of metric tensor or something like this. But this space Y is actually not a vector bundle, because the metric has positivity condition, so it's a bit subtle, and because of this moment it's hard to understand what's happening next. For example, he uses this notation A0 for some fixed spin connection, and the nature of this A0 and its relation to other variables are unclear, and whether it's dynamical or not. And next, he's talking about signature, and he claims he has a choice between 3,7 and 4,6 signature on this 14-dimensional space, and he didn't really prove it very clearly. Or at least I wasn't able to understand his argument. I tried to do this calculation myself, but I'm not sure it's correct either. But hopefully it's not that important. I mean, this is just unclear equality, but it doesn't matter for anything further. Yeah, so the next question is how he justifies the reduction of the SO10 gauge group, which he is getting naturally after dimensional reduction, because the fiber of his bundle of all metrics is 10-dimensional. 4-dimensional space-time, the number of components of metric tensor is 10. And there is no clear justification how to uniquely derive the standard model gauge group out of this SO10 gauge group. It's actually an old story of ground unification theories. People used to play with them a lot, but they predict a huge number of new bosons, right? This means huge number of new decays, including proton decay. This wasn't observed. This theory is getting more and more constrained by experiment, so they're slowly getting more and more out of favor. And Eric, I guess, tried to reignite people interested in them for some reasons. But I don't see any new arguments on this point here. Yeah, that's here. He defines his fields. So basically, he has functions and one form. This letter is actually pronounced as pi. I didn't know. I seen it a lot, but I never bothered to read it. So yeah, and spinors. And spinors were written in one forms. And he's talking about his gauge group. I won't. There's some unclear side remark. Doesn't matter a lot. Here, when he starts talking about A0, yeah, that's precisely the part which I don't understand already. It's more like it will become more unclear when you get to actions. Here, this statement is unclear, and it's actually important for his equations. He said that the map mu A0 is called biconnection. The map is defined here. It maps an element of the gauge group to a pair of connections. And he says that this map determines a pair of sections of this bundle, where T is the total space of all connections. Yes, but B in his notations was equal to N, where it was, it's equals here, and N is just the space of one forms, at valid way one forms. So this notation doesn't make any sense. Like what index omega means. Is this omega basically one form on B? Then how we construct epsilon pi out of it? Maybe this B should be G, and then epsilon and pi are just elements of G, because that's how they're usually called here. That would be more clear. But he writes them like this, and this omega is unknown entity, but it will be repeated further and further down below, over and over again. This part is unclear. Okay, that's more or less clear. This formula we will need further down below. Yeah, this again the same problem here. Again, epsilon and pi are objects of different nature, and he applies these spin connections to them, trying to get objects of the same nature, such that the difference is well defined and N. That's bizarre. I don't understand what he means here. Finally, we get into the Xi-up operators. Here, the symbols need to be better defined. I have to guess what this means. M and N, I guess, are just 0, 1. Because Hochstar square is kind of already 1. And here he's talking about how to define them. He added this complexification step, I guess, which Timothy pointed out to him. Here, which makes basically all the theory complex valued, complicating the interpretation and also quantization, potential quantization of it as a unitary theory, right? Yeah, so he defines phi I as a basis for invariant subspaces of this representation. And he claims that you forget how to build them. I don't know what exactly he means, and maybe I misunderstood something, but if I just even type these things into AI, he already finds explicit versions of these operators. Let's say on degree 1, degree 2, even in basis. And there are actually 2 of them for each degree I. One has correlative operator. I assume he just forgot about the second one, because I forgot about it as well. So he's probably using the only one which he considered, which he thinks is unique in his formulas down below. So here he finally starts writing equations. Yeah, and that's why it's important whether A0 is dynamical or not. And he probably doesn't list it as part of the dynamical variables. He introduced new entity omega, and he writes the She-Arp operator with the index being this entity. So it's unclear. Is this the same as here? The epsilon is this epsilon with index omega, which was not defined, or what? This part is confusing. Also, he has fb omega here, but he has fa omega in the equation, and here he doesn't even have an index at all. So this is just kind of hard to make sense of. I would say, because yeah, this pairing wasn't really introduced either. Yeah, here as you can see, indeed, epsilon doesn't have an index anymore. So maybe this was a mistake that epsilon had an index previously. Also, it's fair to mention what the symmetry of these equations are. Like if this She-Arp operator is basically covariant only with respect to spin group, then the gauge group is the subgroup of what he claims. It's not U128. It's only the spin group. But probably it's fine. Yeah. Actually, maybe he doesn't even make a claim that U128 is the actual symmetry group. Yeah. So that's probably what he wants. Then there is like a big question: how to obtain the Einstein field equations from this relation 9.8. I wasn't really able to do it because he didn't explain how exactly the variables A0, omega, and epsilon are supposed to be reduced. he gave some ideas here in the end, but they're a bit strange. So first of all, what he's doing when he writes it, I really didn't even understand what's going on. He already used this isomorphism between Lie algebra of unitary endomorphism of our spinor bundle with complexification and the complexified exterior powers of our cotangent bundle to y, to u. And that's why he's getting this, that's why he writes omega 1 of y at valued forms like this. And here he finds what he calls space-time cosmological constant, and this indeed is like a second tensor power of Tx. So probably he means that the term like lambda times g mu takes values approximately here, or in subspace, in symmetric subspace of this thing. So I assume he means that this torsion here, where it is, T omega displaced torsion, will become this lambda g mu. So he probably thinks that this one form, omega of pi minus epsilon inverse d0 epsilon, will be, after it decomposes, will have a term which takes value in t of x, tensor t of x, and this will become our space-time metric. That's the way I guess you could interpret what he implies here, but that's hard and it's never written really explicitly, and again, it's not clear even what happens to antisymmetric part of this tensor. Does it it falls out of the equation or what? It doesn't seem so. And of course, it's all very strange because in the original equations, these two tensor, these two spaces, right, left and right side of the tensor product are treated very differently, right? All our differentials act on here, and this is just understood as a coefficient. But here they should be on the same footing already, right? After the reduction. In the metric, they're literally just symmetric. So it would be a bit unusual. Okay, so yes, then he moving on to Young-Mills equation, which I haven't even checked, and Young-Fermi equations. And there is a bunch of undefined things here. For example, this notation was not defined, not clear what's going on here. The pairings are not defined properly, and these stars, omega star, wasn't really defined either. So I just have to guess what's going on here, and I'm not sure I could guess correctly because I'm running into contradictions between these formulas. My guess is here, and my guess is for the same notations down below. This last equation is not really obtained from the Lagrangian. I don't know where it comes from, which is kind of out of the air. But I guess it's fine. I mean, this, I guess, is maybe a typo. Maybe it should be T omega star. I don't know. Then he writes his complex, which is like taking the square root of his bosonic equations. So that's the idea. He's trying to write down fermionic equations in the form of complex, such that differential square to zero condition gives us bosonic equations of motion, like Einstein equations, Young-Mills equations. That he does more or less correctly. There are some typos here. There should be no new bar, it should be just new. It should be no zeta bar, it should be just zeta. Here, the torsion part was unclear to me, wasn't able to verify that. And there is some, I guess, unclear problem here with zeta, at zeta star again. It didn't quite match, and I don't know, it was hard to guess what he wanted to see there. And kappa 2 star appears first time. Not clear why is it here. It was never introduced before. I guess not important. Yeah, then he goes on to make prediction for the generation out of it, because I guess the logic goes as follows. He only needs degree 0 and degree 1 forms to get the complex such that q squared differential this complex equals 0 gives us Einstein and Young-Mills equations, so that that has to be everything. That has to be all the fermions. So we have like 2 generations plus, because when we take tensor product of one form with spinor bundle, we also get this Reda-Schwinger term. He says like the third generation is kind of, handicapped or a little bit different, and he predicts, if I could call it that 3 generations behave differently, but at some high energies beyond SU10 ground unification energy, I guess. And he predicts much of, I guess, in the particles with like unclear unspecified masses, because mass is just not covered in this draft at all. Like, what are the masses of these particles? Which energy scales this all happening? That's not clear. So yeah, I guess that's technical problems with the draft. The main problem, of course, that it's just some classical theory, which again hasn't reduced Einstein equation yet, and yeah, of course, it has no quantization and no even clear way in which it could be quantized. Like in 14-dimensional space, you probably will not have renormalizable theories at all. And here he has to complexify everything. So the meaning of this 14-dimensional gauge theory becomes very obscure, right? It's some auxiliary space. How to obtain physical dynamics from it isn't clear. So yeah, quantization is just not done at all. And because the notations are not introduced properly, it's hard to verify anything. Yeah, that's more the end. Yeah, he has appendices here, which is supposed to help with shear-up operators, but they don't quite help. Okay, that's a brief summary for those who don't want to watch the whole 2.5 hours lecture, which makes sense because it's kind of probably useless. See you next time.